Okay, so then talking about generic building forms, so going over some of the concepts that we went through in lecture and in your book, just giving us a brief explanation of where your site is and what kind of, from what you understand currently, from what we've learned so far, what would be your current assumptions, right? Then you're going to select your occupancy type. So we talked about occupancy, so this shows you how to do it in Revit. And then you can import or draw your site. So if you guys are already working with the site model, you can bring in your site model. If you have a site plan, you can bring your site plan. The steps here to do that are on the side. I also have a tutorial that shows you how to take GIS into QGIS into Rhino and Grasshopper, which you can then bring into Revit. So if you guys don't already have a site model done, you can use that to generate it for you. So it saves you from actually having to model everything from scratch. It's a little bit cut off, so I'll fix that and update that. But that's a pretty good tutorial for you guys to go through if you don't have your site model already done. So after that, you're going to set your survey point and rotate your project to true north. And then what I want you guys to do is basically come up with 3 conceptual mass options, right? We talked about different building forms and building shapes. And I want you guys to come up with 3 configurations based off of your current assumptions that A, match the climate, the microclimate, the macroclimate, and the microclimate of your site based off of your assumptions from what we learned, but also your program for your site. So you guys are all going to have different program and different conditions for your site, for your studio. So try to do the best to blend both for the different options you choose. And then also referencing the conceptual mass modeling we showed you in the workshop for Revit, right? That tutorial is now online. You guys can find it through Canvas under modules. So once you do that, there's some steps to change the way that the solar analysis looks for graphic representation. Those are the steps for that. It tells you how to set up the solar analysis. And then basically we want you to run the solar analysis for all the 3 options. And then from there, we want you to select the option that you think is best for your site based off of the analysis and your understanding currently for the site, right? After that, we want you to then, from that analysis, add things like window overhangs and modifications to the form to further optimize it, to kind of see like, okay, we looked at what's the best option. We analyzed it with the Insight360, so now to see how can we slightly modify it to make it that much better. And then the last step is basically then taking that model and changing its climate zone to see how that might differ. So if you're in Miami, for example, we want you to use a location that's an opposite climate condition. So if Miami's hot and humid, I would suggest you use something like Santiago, Chile, which is cold and arid, right? And try to pick something on the opposite hemisphere. So that way you can see the difference between having the sun coming from the south versus the north, and then giving us a brief explanation why and what you understand about that. So when you do conceptual design, you're typically looking at 2 things, right? We're looking at solar, sun paths, but also prevailing winds. So the first part of the first assignment is based off of solar. The second assignment is going to be focusing on CFD. So Miguel's going to walk us through the solar and Insight, and then if we have time, we're going to talk a little bit about CFD, so that way you can at least start using it for your studios. Make sense? Okay, any questions? Okay, so Miguel is going to take us into, let me just open up the file, take us in through the steps and processes to do this. So when we get to CFD, there is, we noticed, well, I just learned today that there is a bit of an issue when you're downloading. There's a way to download through a browser download versus the typical way you download, and that will resolve any issues for installing the software. So for me, for example, I installed the software the other way, and when I tried to open CFD, it didn't open. So if we have time today, we'll explain what that is. Okay, anything you need? That's okay. All right, guys, please give Miguel his attention. And again, Miguel, thank you so much for doing this.
No problem. Good morning to everybody. The ones in the back can hear me good? Yep, thank you. All right, so the first thing is to understand why are we using this. let's say that we have different forms and shapes, the ones that you're gonna use. So the very first step is to place them on the side that we're gonna have using a basic logic. You can start thinking on entrances, exits, views, or whatever. From there, we're gonna go to analyze, and having one of those masses, we can go to solar analyze. And we can get the solar energy annual PV or just custom. Here we're gonna use all mass faces. The difference is between each other is that when you use all mass faces, you're gonna automatically use the masses that you have in it. It won't use like walls of concrete or walls or windows or roofs, grounds, nothing like that. Just the mass. If we click on here, we'll be able to select what sun settings we want to use, or if we want to use a full annual setting. And then we can go to update. Once that you click there, it will start making the analysis. Okay. Well, it seems that it gave me an error, but let's see if it loads. Okay, so we're having this. Okay. So if you see here, we have some results for the mass and how the sun affects it. So one of the things that we need to do is change the styles and select the colors that we're gonna be using as the exercise says, which is basically this tree. We have to adapt the legend to those three colors: red, yellow, and blue. We come here. Here we selected the max. It's gonna be red. Then it's gonna be. Okay, give me. So once that we are here, you select the element that is being analyzed. Then you go to edit style, and then here on analysis default, you go to color. Then you modify it. Okay. You can modify the legend too. So you can have you can set the size of it or the text or different points for the description. But now, one of the things that is important too is to understand what we are looking at. So this shape is pretty interesting because the sun doesn't affect it very like regularly because it has so many interceptions and different shapes. You can see how this part is being more affected by the sun, but this one on the bottom is not so much. So what are you gonna do with that? You want to select those points, those faces, and think of them as the most or the best ones for putting your windows, for instance. You don't want a lot of radiation coming to your windows, so you will look for the faces with less amount of energy coming through. These ones are gonna be the blue in this case. If we see the other ones, we can see like these faces and this point are getting to the east, or these spaces are like carved from the main mass also has less amount of sun coming in. So you choose what you will do is select one of these three shapes that you already have. You're gonna run with these results. You're gonna select which one is the one that has the best performance. In this case, I would say that this one has an interesting performance that we can use, but this one also has it. Because it has some surfaces that you can adapt and you can use, even though if they are looking for the south or the north or east or west.
So you guys are in design 9. Are you guys currently doing massive models for your site?
Yeah.
Not yet? Well, so for the ones that are, and also whenever you finally get there, you can use these techniques that we went through with the massing and the NURBS modeling in Revit to quickly modify masses in order to run them through and start to get immediate feedback about what kind of conditions are going to be good for surface area to volume ratio, what's going to be good for solar analysis, and then how can you then rotate or modify the form to get an optimal amount of sun exposure on areas such as, like, let's say, so in this case, where you have blue, that's probably better to have a window, right? Whereas if you have red, if you're in a hot and humid climate, you probably don't want to have windows there. So you're going to be looking at things like your site conditions, like where you want to have views, where's the access to your site in order to make the form, but then also taking into account the solar radiation that we're looking at here. And of course, prevailing winds, which we're not doing for the first assignment, but we'll follow the second assignment. But you guys should already be thinking about prevailing winds from conceptual design already.
So once you choose your mask, you have two options. You can get to use the mask and just add the windows wherever you feel you think that it's interesting to add them, or start thinking on shading devices or shading elements. But also you can modify a little bit the mask, so you can add more shade to some points, or maybe create some different things that will help you on the future. So that's basically the one. Once you start the process of choosing and improving this design, you can just keep redoing the analysis as much times as you want to see what's the best efficient. I recommend that if you are gonna do this, you should put on your assignment all the different variances that you are doing. At least if you are modifying a lot and you're having different results, at least add one page with the small captions, so your professors could see like you are also modifying the shape to improve the conditions. Okay.
Guys, we're trying to design this in a way that you can use this as a potential requirement for your studio. I mean, I know every professor's going to have something different, but for the most part, for the sustainability studio, you guys are going to be required to do an analysis, a solar analysis, and the wind analysis. So this is allowing you guys to do both at the same time. So hopefully saving you time, but then also reinforcing the lessons that we're looking at in the lectures.
Also remember that you can change the orientation of the element. For instance, in this case, this one, its longest facade is on the south and north. The south is the one that it has the most solar, like the solar radiation hits the most the south in this place. So maybe you want to change it a little bit, or move it, or rotate it, so you can like work with that. And the thing that is going to help you doing it is these results, because as you are seeing, all the south facade here is in red, but because of the different elements, you have less radiation here, even if it's on the top. Actually, it's interesting that you kind of work with that. So maybe,
guys, I made all these forms from the same process we went through in the last workshop. But I think on Tuesday, if we have time, I'm going to show you how you can bring in models from either Maya or Rhino directly. So it's not an exact science. Sometimes you bring in a really complex model and Revit just doesn't like it. So there's a little bit of in the original environment like Revit, there's a little bit of give and take that you guys have to be working with.
So you could rotate it, you could adapt it, you could add specific devices, shadings, walls, concrete walls, elements that will ensure that this facade here will be protected. All of these you should have it for the next step of the assignment, which is basically making the model the best of what you can make, so it works very good. So what I want to do now is basically go a little bit with the process again and from the very beginning. Have you started with some of these elements? With some of the configuration of your files of Revit? You have a site. Have you started modeling that site on design? No?
So when you guys import your site, if you have a 3D model, it'll affect the shadows on the model, right, Miguel? If you have a surrounding
yeah, context. I mean okay. So what I you can go to CAD Mapper or InfraWorks to get the models on 3D. You have the buildings around that will help you to see how the different conditions affect the model. Then you will place your building in a site with a specific constraints. I don't know if you are they using like codes and things?
Like scripting?
No, codes of city codes.
It depends on the studio. I think most of you guys your sites are in Miami, but it depends on.
Well, if at some point you're gonna have to add setbacks, FARs, and different constraints that will shape somehow this model. And then once you have that mass, you go to this point. The thing is that if you are gonna do it on Revit, the first thing that you have to do is to go to the location and add it. So basically, you go to Manage on this tab, you go to Location, and here you will choose where your building is gonna be. So if it's Miami Beach, you just look it, click on it, and it will give you a specific zone. If you see there are more, there are like 3 more on this area. So you basically should choose the one that is closer to your site. That will ensure that your results are going to be the most accurate possible. So let's say that I choose this, then I go OK. If you see the assignment, in the location, weather, and site, you will see some specific parameters that are already on there.
So that gives you the dry bulb temperature, right, which is like what you get from a thermometer, and the wet bulb is what you get if you wrap that thermometer around a wet cloth. So it's like basically whenever you're measuring heat plus humidity, that's going to be the wet bulb temperature. But what I want you guys to do for that slide is to also give a brief description about the climate. What are some of how many heating degree days versus cooling degree days do you need, and what does that mean for the design that you're proposing?
So again, you go here, you click on weather, and you will have all these parameters here. Is mostly at this point is it's important for you guys to be able to understand what you are looking at and interpret it, like Albert said.
And make sure that you have the location set up from the beginning, because if you run your analysis without that set up, you're going to get all the data is going to be wrong. So Revit has all the building codes, the comfort zones for people, as well as the climate data all built in. So that helps you a lot, but it doesn't do anything if you don't select the right location. So make sure you're selecting the right location and the closest weather station to your site.
So once you choose it, remember sort of these results, maybe they're going to be similar, but probably they're going to change. If I go again and I run another solar analysis, almost faces, custom, okay, apply, update.
So there's 2 different options. So right now Miguel's running the all mass faces, but you could also change that to select the surfaces you want. So you could do each facade individually if you wanted to.
So that's something that you will use once that you choose the one and you start tweaking it. You add the windows, you add solar shading devices, and then you go and you select all of them as the surfaces that it's going to analyze. In that sense, you will be able to check if the sun is hitting your facades through the different protection elements that you're using, like louvers. So these are the results here in Miami Beach. They are pretty similar because it's the same hemisphere, but if you remember, this part was already getting red on Boston, while now all of this is yellow. So these are small things that can modify, but also you can take advantage of whenever you are gonna start adding the windows and different elements. Another difference is that before this was more blue and the intensity of certain spaces changed. So let's say that you start adding different materials. Let me see. Measures result. Okay. So if this is my mass, I can go to massing on site. I can start adding some walls of it. So I could say that this is a wall. Just clicking the face. If I want to add a window, let's say on this facade here, you cannot add just a window on a mass face. Okay, so you're probably gonna go to curtain system and select the face that you're gonna do it, and you're gonna create a system that will create a gridded surface where it's gonna place all the windows on different panels of it. So in this case, it came like this.
So we had this question from last workshop, which I'm not sure if we're completely resolved on it yet. So whenever you run the insight, does it take into account these materials? So right now you're adding the wall and you're adding the window. Does the solar radiation take all that information into account?
When you make the solar radiation analysis, it will understand that a concrete wall is a solid material and it's gonna absorb energy, but the windows usually doesn't get it. So what you may want to do is to select the mass like the face of the mass. But if you're gonna use a grid system with different louvers and elements, you may want to select all the louvers. So whenever you put the sun, you will see how that face of that mass is being affected by all these elements that are protecting or reducing the amount of heat that it's gonna get.
So when you run this analysis, you wouldn't select the windows?
I wouldn't select the windows.
Does that make sense, guys?
Actually, I don't even think that it lets you select the windows.
Okay.
It will just go with the grid with the with the louvers, no, with the framing and these construction details. Because then, if I have these two elements here, let me just put in system. So I'm gonna go to curtain, and in curtain panel, I'm gonna add glazed. Let me just glazed. So now it added a material there. So if I go again and I go to analyze, I click on solar. If I go to almost faces, it's gonna do the exactly same thing that we already had. If I go to all roof exterior surfaces, it's gonna get whatever it understands as roof, but that doesn't count the walls. Okay? So we can go to user selection. You're gonna pop this. Then you start selecting the walls, like this one, or this other one, and this one. And maybe the one that is gonna be behind this grid system. Then I will click here on finish. And I'm gonna go to update. So it's gonna just analyze those specific phases that I'm asking it to do. So as you can see, this one get a lot clearer. This one keeps the same colors, and this started to change a little bit just because of the grid system. So once that you come to this part, you want to be very truthfully, like you want to check every single element. You want to select every single element to see how this new shape with these solar elements or solar devices and the amount of sun hitting it will behave.
So adding those materials like the wall and the current system just makes it more accurate.
Yeah. No, yeah, but once that so let's say that you go to the masses and you analyze the masses and it give you a result. That result is gonna tell you how you're gonna improve it, where you're gonna use the concrete walls, where you're gonna use the grid systems, or where you're gonna put the windows. Because you can also put a concrete wall and then start putting windows on it just by yourself. It'll take you a little bit more time than adding a grid system, but it's a different way of doing it. So that once that you put all the walls, the windows, the shading devices, and you oriented the building better if you needed to. Once that you add the buildings, you add the ground. Once that you add all the conditions and all the improvements that you're gonna add, you can run the analysis selecting the phases that you want to check, and that will give you a better understanding of how your building is gonna behave with the sun. Okay. So in this point, let's say that I choose this one from all my masses because it's the one that behaved the best. And then I add materials and I start working with the materials in order to get a better result on it. Okay?
And an added advantage of working with the masses, like we saw from the workshop, right? You can go back and modify those masses and then update the faces so all your materials update as well.
Yeah, so you don't have to like change or eliminate the wall, put it again, or create a different mask. You just modify the mask and you just update it. Let me see if I can do it here.
I mean, they have it from the last workshop. They can
Okay.
reference it.
So in that way, you will have a most efficient design on the very first stages of your project. Once that you finish choosing and placing the materials, adapting everything to the conditions that you have, then you probably will get to analyze with CFD. CFD is the second assignment, I believe. I mean, okay, the sun analysis is not like quite complicated. It's very simple. It's you locate it on the place and then you run the analysis. You run the analysis every time that is necessary, with the modifications that you have, with the adaptations that you make. But basically, it will give you the results pretty like straightforward, and the settings are mostly the location. If you want to modify other things, maybe you can go to sun settings, and here you can play a little bit more with the things that you are doing. But I wouldn't recommend you that because Revit already has a lot of information set on the Insight360 plugin and how Autodesk works with it. So if you see, it already has the location, has the time for the multi-day analysis, and try not to do a lot of this when you are designing. Just go to manage location and take advantage of the software and the database that it has, which is very good.
Can you show them how to add the sun path?
Yeah. So if you have the sun path, you click on sun path on, and it will give you this.
Right. So that's all the options for where the sun could potentially be from winter to summer.
Yeah.
Right?
So basically, this is the movement that it will have alongside the day, and this one is the one that it will have alongside the year.
So when you guys are explaining your macro climate, please include options for summer, winter, equinox, right? All the different times of the year, and it can give us like a brief description about why that's important and what that means for the site and the model you're designing.
So if you see, I mean, this is something that you can get into consideration too. If you see all the year, it's more south than north. That means that the south is the one that is gonna get more affected.
Hemisphere, right? The southern hemisphere would be the opposite.
Mm-hmm.
So in winter the sun is lower angles, and summer the sun is higher.
And then if you see, so if I move it here, I'm basically moving the time of the day, and if I move it here, I'm basically moving the day of the analysis. So this
reacts according to that change, or is it something you can input it manually?
What?
If you run Insight right now, after you change the sun, will it update to that sun, or you still have to input it manually?
I can use it. The thing is that if I come here, like sun settings, and here I set how I want the sun to be at that point, then I can go to my analysis, and here I can select solar energy and custom, and here it's going to use the sun settings that the file has.
Oh, okay. So when you move it, it's gonna update.
Yeah. Although in this sort of setting, I mean, if you move it here, it's just for you to see. The only way that you can program the file to react with that is that you go to sun settings and you specifically here add the specific day, time, and hour that's gonna be working. If not, it's gonna keep doing the yearly because that's how it's a multi-day study setting on the sun settings. Either if I'm graphically moving, it's still being a multi-day like setting. Okay.
So when you're running that at the solar analysis insight, the setting is set for the entire year. So it's taking into account every particular motion of the sun.
So alongside the year, this wall is going to be affected differently than this one, but it's going to be alongside the whole year. If you go to a specific day or on a specific time, then maybe you don't have any sun here on this face, which otherwise was the worst one. Okay? That's the good thing about the multi-day because it's an average and usually works pretty good for you to understand the amount of heat receiving that specific building alongside the whole year and the whole life of the building. So, okay, going back again. Once that you have different ways of reaching the same point. If you go to location, you add your own location, you set the orientation of the building, and then you go to solar analysis, and then you use a custom multi-day solar, or you can come here and make your own settings. Even if it's a multi-day, you can go to multi-day, and here instead of January the 1st of 2010, you can go to 2020, and set everything to this day in particular, to this year in particular. And reach, and then you have to be careful with the times too. So let's click sunrise to sunset with the date, the place. We go OK, and then here we go to solar. Use sun settings again. User selection. We selected this one, this one, this one, and let's select this one too, just to see how the facade behaves. If you want to remove a face, you just click again on it. It automatically goes to plus. Okay. Finish and update. So it's the same multi-story analysis for this year in Miami Beach, and look at the results.
And that's because you changed what exactly?
I put this year, and I ensure that it's gonna be sunrise to sunset. So that's another thing. You have to check every single element to see what's the result that it's gonna get. Because last time maybe it wasn't a specific time, it was the worst case scenario, and now that it's all the day, you see how it really reduces the incidence of the sun here. Okay?
You guys have any questions? Really quick, can you show them how to get to the building occupancy type? How they can select that?
Okay, if we go to manage project information. On energy settings, this is the first step. Let me see.
Building data.
Building data. Wait.
Right there, building type.
Building type, office. We can go to, I don't know, school or university.
So depending on your studio, you're probably going to have different programs. Make sure that you're selecting the right occupancy type.
Yeah.
Because that's going to change all the data built into Revit. So that's going to control all the information that when we get to the pre-building studio, all that data that is collecting from your model is going to change based off of that occupancy type.
Of course, once that you keep going, at some point you're gonna start to establish the occupancy or the type of occupancy of different rooms or spaces in the building. At that point, you're gonna put more information. It's gonna be more complete. But that's gonna be like what, the third assignment?
Probably.
Okay. Another thing that I wanted to. Okay, so basically with this we finish the sun. As you see, it's very easy. You just have to put the correct information, the correct location, and it will give you different results with that information. Um, Although the multi-day study with the whole day analysis is very good, I will encourage you guys to try that one, and also the ones that is the worst case scenario. Because in the normal day-to-day, when you're designing a building, that worst case scenario can be a lot more energy that the building is going to absorb than the average of the day. So you're going to spend a lot more money because you didn't take into consideration the noon versus just taking that into consideration, designing for the worst case, and that's all. Am I myself clear? Okay. So do a little bit of research, check where the sun is the worst in each case, maybe do different analysis. You can do that. You see, it doesn't take a lot of time. You didn't have to modify anything. You just change the time here on the sun settings.
So you want to try to find the peak loads for the thermal loads. So for Miami, you want to go maybe to the middle of the summer and pick the hottest day of the year and run it in 4 p.m. right after it's been in the sun all day. And you want to design your systems and your overall form according to that worst day that you need to add cooling to the building. Same thing for winter. You do the same thing. You go in the middle of winter and pick the coldest day of the year, and then run the analysis and see how maybe you could then optimize for direct solar gain by adding a window on that south facade in the northern hemisphere, right? So that way you can use the sun for heating as a passive strategy.
So you have different, as you can see, you have different ways of approaching this issue. Just try to think that what the sun makes is that it heats the space and makes you consume more energy. That's what it does here in Miami. So try to design taking that into consideration and to sort of design against that condition to be more efficient on energy-wise.
And just keep in mind that there's really no right or wrong for these kinds of things. It's design, right? And I think that the assignment's set up in a way that you have to just basically explain why you're doing and what you're doing. And as long as it makes sense, you're going to get the points that you need. So just try to be really specific and clear about what you're doing and try to show us in the most concise way possible. And you'll get the points for the assignment.
So once that you finish the sun, you are ready. You do your analysis of your three shapes. You choose the most efficient one. Then you modify it or adapt it to make it even more efficient. You do another analysis, and then you basically explain what your results and how it improved and why it improved. Okay. From there, you will have to change it to a different location and do another analysis. Once that you finish the solar analysis, the next step is to do a wind analysis with CFD.
Before you jump into that,
Yep.
I just want to show you guys really quick. So in the example, I did this really quickly, but you guys are going to do a much better job than I did. So for example, whenever I selected my best option as this one, and then from that I added where I would add. So in this case, these are like what I would imagine a louver system or a recessed window, so that the window is not getting direct sunlight anymore. So now it's more gray or more purple in this case, so it's not receiving direct sunlight. So you guys can do this through overhangs, through changing the form of the building, through recessing windows back, right? To basically when you pick your windows or you pick your views for your building, you're making sure that they're not being fully exposed to the sun, unless that's something that you want to do. If you're in a cold climate, then you probably want to do that in a way so that during the coldest parts of winter, you actually are getting that direct solar gain on the windows to use it for passive heating. Okay?
Okay, so once that you finish the sun step, you're gonna probably go to CFD. And we wanted to tell you a couple of things about the software, so you don't get to like you know a little bit where you're going. Um, the first things is that you go to CFD, you go to CFD Ultimate, and you will download the latest version, which is 2019. On here, you will go to this, and you will probably have this option checked, Install Now. Don't use Install Now. For some reason, CFD is having issues with that. So go to Browser Download, and you're gonna start downloading here. Once that is finished, you will just click here and start installing it. What is CFD? CFD is the name, the letters go for computational fluid dynamics. Basically, wind is a fluid that you will analyze in your building. It creates a specific surrounding or a condition box, I think that is called on the software, and you start adding different elements on that specific box. So you will put the direction of wind, the intensity of the wind, the temperature, the overall temperature, the overall humidity, and that will give you the results of how the wind is going to behave with that specific mass. Why are you doing this? Okay, so there's the main thing on it is that depending on your design, the wind is going to behave in different ways. It can create voids that usually on climates like this one, it will be the most warm or hot place on the building because the wind is not going to be able to pass by there. So it's going to move and maybe create different waves or behave with the different facades in different ways. You want to avoid that and modify the design so you can properly use the wind to create cross ventilation or to increase the I forgot that word. How people feel in it. Okay. Also, you can see that if you have a really tight space, the wind is gonna go faster and it's gonna be uncomfortable too.
So you guys can reference your book and see the general forms, the general design strategies for natural ventilation. But the book examples, they're very basic shapes. So you guys are going to have more custom shapes depending on your site and depending on the way that you design, especially if you have really fluid and curvilinear shapes. It's kind of hard to understand how that wind will react because it's not so straightforward. So by running CFD, you can get a much clearer example before you would go into something and start constructing this building, how wind might react in that building and how you can minimize loads and energy usage that you would otherwise have to use for ventilation or HVAC.
Also, it will give you the temperature of the wind in specific points according to the sun and the humidity. And in that way, you can also add that to the results of the sun analysis and see which facades are going to be more hot or absorbing more thermal energy. But
really quick, guys, whenever we skip this part, but whenever you come into Revit, when you create your 3D model and you want to import it, you can import it through the Insert tab. And then if you have a DWG, you could use Import CAD, and that way you can basically import either your site plan or you can import your site model, right? So here you have the option for DWG. If you're taking it from Rhino or maybe even Maya, I'm not sure if Maya has SAT, but Rhino definitely does. So if you're working in Maya, you can bring it into Rhino first and then export it that way. But this is the one that you would use, .sat file. And that'll bring it in the cleanest in Revit, so you can then use it as a generic mass. And if we have time on Tuesday, I'll go over that a little bit more.
Another thing, if you're going to use the topo surface or the site, for Revit, it's better if you use their own system. Like they want you to use the topography tool that they have. With that, you can shape the ground, or whenever you put a section, you will see the ground hatch. It's easier for you to specify the different spaces. So if you're gonna use it, you go Massey and Site and Topo Surface. You can import a CAD file where you have the lines on the different heights, and it will automatically use it, and you won't have to do anything else. I would recommend that this always, like for setting your file, because even the analysis, the CFD, sun analysis, it understands better that as a surface than anything else. Okay, and if you're gonna import a DWG, try to do it on mass option. Like if you create a mass option, you bring a DWG, so it understands that as a mass, and you can start modifying and putting walls and things just by selecting the faces.
Anything else?
No, because the CFD is not like really downloading.
Maybe it will. Okay. That'll probably take forever.
Okay.
Let's see it really quick. Change site. 3. Went over that. Set your north. Do you want to?
Set true north.
Yeah, maybe we can go to the survey point in true north.
Okay.
Yeah, this tab is.
Actually, that tab that you show there, it's more of the next assignments.
Okay, that's fine. We can change that. Okay, so maybe you can show them the true north.
Okay, another thing is the true north. And okay, so when you have a mass, you have two different north: the project north and the true north. The true north is the one that is gonna be based on the location, and the project north is the one that is gonna be based on how you're gonna set that project into the plans and the composition that you're gonna make.
So like this one, for example, this example is pretty long. It has a general aspect ratio of a rectangle, right? It's longer in one direction than the sides. So you'd probably want to make the project north. You'd probably want to rotate it 90 degrees. So that would be your project north. But the true north is going to be based off of your site. So when you import your site and you have that direction correct for the true north, then you're going to set that up so that whenever you're actually modeling and drawing in your plans, you'll work in the project north. That way you can try to it'll save you a lot of time trying to align things. But then whenever you try to run your analysis, or you're trying to take your maybe site plan, you want to make sure that you're in project north, true north.
Yeah. So how do you change that? Then you get to manage, and then here you have the project position. What you're gonna do is rotate project north in this case. Okay. So let's say that I want this because of the side goals or whichever. I want this to be on the complete, like, different orientation. It's gonna be rotated 180 degrees. So I can go to here, rotate project north, and then go to 180, and it will look like this. Soon. So it says that has successfully processed 1,881 elements. And then if you see here, you see that it's completely rotated. The good thing of this is that if I go to my sun settings and I put the sun path on, the sun is still working with the actually normal way. It's going to the south with the true north. Okay, so the project north is basically just a reference, more like a graphical tool to be able to put the project wherever you want it, so you can like work better with it, or it's gonna look better on your sheets and so on. The thing is that you only have one project north. You cannot have several. So if, let's say that you want to put in a certain point, you want to make this project to go vertical from the beginning of the project, you have to choose either if you want to present it horizontally or vertically, or oriented this way or that way. Okay. Once that you do it, you just stick with that. Sometimes you can rotate a view, but it's not the best way to do it. And another thing of this that you should take into consideration is that if you're doing with the true north, you're working with the true north, and then you put a model here, you want to, on the orientation option of the properties of the view, that means that I'm on site, I don't have anything selected, I come to here and I look for orientation, I can set true north and it will rotate the file. So I can work with the true north in this case. But that's not going to change how it's going to be added on the sheets. Okay? Is that clear? So sometimes you're going to have the true north when you start, and you're going to try to change the project north, and it's going to be like blocked. So you need to get here and select the project north, and then once that you're on project north, you can modify it however you want. Okay? So don't freak out if you see it like that, like. Anything else?
If you can show them the survey point, how to turn that on. So the survey point by default is hidden, but if you go to your visibility graphics, you should be able to find it in, I believe, site, yeah. You just want to make sure that's turned on. So if you don't have it, you just want to make sure it's turned on, which the template shows you guys how to do that.
This is survey point here.
And CFD is still loading.
Okay, let's see if now it opens properly. Should.
So we're going to go over a little bit of CFD today, just to introduce you guys so you can start to use it for your studio as a design tool. But unfortunately, I downloaded it the wrong way, using the browser download and not the. Is it the browser download is the right one or the wrong one?
Browser is correct.
You make sure you use the browser download, not
Yeah.
not the default one. I used the default one, so then we couldn't open it. So make sure you do that.
You will need to get to your information. It will give you the serial code, and you need to add it.
Okay, so we can't use it now.
I can run it as a test right now within 30 days.
Sure.
Just remember that.
Sure.
But using your guys' serial code.
Okay, so we can do it next time if it's gonna be.
Yeah, you have to add that. So okay, no, but it's good that. So whenever you download it with the browser download, it's gonna pop you these activation options. You probably should receive an email with that information. But if you don't, or it's easier for you to look on the Autodesk Manager, you will get that same data. Okay. You just add it there, whichever it is, and then you go next, and then you should be good to go. The problem with CFD 2019, and it's a problem that they had all the year, is a problem of license. So whenever you download it, it will crash the license service file, and then that's why you have to do all this. Basically, just like a side note. Oh, since I open.
We have 5 minutes if that's.
It's gonna be more complicated, maybe.
Okay.
Yeah.
Okay, guys, we'll probably do this next time because it might get a little bit too much for one day. But we'll go over this maybe next week or the following week. Do you guys have any questions on this? Yes. Is it due February 15th?